Alright, today we're going to go over your math test corrections. I'm going to try to put up which number I'm working on so that you can kind of skip through the video to see which numbers you need. We're obviously going to start with number 1. Okay, and I'm going to go ahead and get started with solving number 1. I'm going to use a blank sheet of paper just to show my work and to have a clean space to work on it. So number 1 says, when adding the fractions 5/9, 1/5, and 2/3, what would you use as the least common denominator? So least common denominator, my denominators are my bottom numbers. So I have a 9, a 6, and a 3. So that means I'm going to make a list of multiples for 9, 6, and 3. Count by 9s, count by 6s, count by 3s. And I see that they all share 18. There are other numbers that they might share if I keep counting out. However, 18 is the lowest one that they all share. So my best answer choice for number 1 would be A, 18. I'm going to move on to number 2. Number 2 says, which two fractions have a sum of more than 1? First thing I need to know is that word sum means the answer to an addition problem.
Staff, if you have the carpool clipboard, please call the office at pound. Carpool clipboard.
So this means I need to go through each of my answer choices and I need to see which one actually has an answer of more than 1. So I'm going to start with answer choice A, and that is 2/10 plus 3/5. I'm going to see what the answer to that is. So 2/10 plus 3/5. Right now they have different denominators. So I'm going to set them equal to give them common denominators here. 5 and 10 share the multiple 10. So 5 times 2 gave me 10. So I'm going to do 3 times 2. That gives me 6. This gave me times 1, so times 1 here. This gives me 2. Add these two together, I only get 8/10. That is not a sum more than 1. So I know answer choice A does not work. I'm going to move on to answer choice B. 2/6 plus 1/3. 2/6 plus 1/3. I can look at that and tell that that's going to be a little bit of a smaller answer, but I'll try it just to make sure. Set it equal to a common denominator. They both share 6, so this remains as 2/6. Here I multiplied by 2, so I'm going to multiply my top by 2. So I get 2/6 plus 2/6 is 4/6. Again, that is not more than 1, so that's not an answer choice. I've marked it down to C and D. When I look at C, C is 1/3 plus 2/5, so I'm going to try that. 1/3 plus 2/5. Well, what denominator could they share? 3 and 5 could share the denominator 15. 5 times 3 is 15, so I'm going to do my numerator times 3, which is 6. 3 times 5 is 15, so my numerator times 5 is 5. I have 5 plus 6, and that is 11/15. Still, C is not greater than 1. That means D must be my best answer choice, but I'm going to go back and check my work anyway. D is 5/12 plus 4/6. So D, 5/12 plus 4/6. They share the denominator 12. So this is just 5/12. 6 times 2 is is 12, so I'm going to do 4 times 2, which is 8. 5 and 8 is 13/12. This is more than 1 because my numerator is larger than my denominator. Okay, it's an improper fraction. So D would be my best answer choice there. Moving on to number 3. I'm going to solve what is the sum of 1/6 and 9/8. Again, that word sum equals the answer to an addition equation. So I have the fractions 1/6 and 9/8, and I'm going to add those together. I have a couple of options here. I could already find a common denominator, or I could realize that this fraction is improper and turn it into a proper fraction, and then find a common denominator. Just to simplify my steps, I'm going to leave it improper and find a common denominator where I am, and then change it at the end. So I'm adding those two together. 8 and 6. I've got to think, what denominator can they share? These are more difficult numbers, so I'm going to list out my multiples. 6, 12, 18, 24. 8, 16, 24. They share the denominator 24. Put that down here as an option. 8 times 3 is 24, so I have to multiply by 3 here. That gives me 27. And this numerator should still be bigger, because the numerator over here was larger. Okay, 6 times 4 gave me 24, so 1 times 4 is 4. 4 plus 27 is 31, and I have a denominator of 24. So I've got to, when I look at my answer choices, there's my answer, 31/24, but when I look at my answer choices, I've got to figure out which of these answers is actually equal to 31/24. So that means I have to convert this fraction into a proper fraction. So I'm going to see how many times will 24 go into 31. It goes 1 time. That's my whole number. And I'm going to see how much I have left over when I subtract that. So I have an 11 here and a 2 here. 11 minus 4 is 7. So I have 7 left over. This is my numerator, and I keep my old denominator, which was 24. So my new fraction is 1 and 7/24. When I look at my answer choices, that means the best answer choice would have been C, 1 and 7/24.
Hot, 248, copy number 248. Please report to the office.
Moving on to number 4. Moving on to number 4. What is the value of 3 and 1/5 minus 1 and 3/8? That word value means what's the answer to this equation. So I have 3 and 1/5 minus 1 and 3/8. The biggest thing to do here is to go ahead and write them vertically and keep my work organized and neat so I don't lose track. So my whole number here was 3, my whole number here was 1. I need to find a common denominator between 5 and 8. They share the denominator 40. 8 times 5 is 40, so 3 times 5 is 15. 5 times 8 is 40, so 1 times 8 is 8. I'm left with 3 and 8/40. minus 1
Carpool, we need
and
6,
15
4,
40ths.
7 up front for carpool.
So I have to borrow here because if I have 8,
Caleb Cologne.
I don't have the ability to
6,
take
4,
15
7
away.
up front for carpool.
So what I have to do is borrow from my whole number here. If I turn this into a 2, I have to put my whole number over here in fraction form. Since my denominator is already 40, I've got to think, how can I make a whole? How can I add a whole over here in fraction form? Well, I can add 40 40ths because this is one whole. So that gives me 2 and 48 40ths minus 1 and 15 40ths. Okay. 48 minus 15 is 33 40ths. And 2 minus 1 is 1. So if I look at my answer choices for number 4, the best answer choice is C, 1 and 33 40ths. Move on to number 5 now. Number 5 is a wordy problem. It says, what statement is true about the sum of the expression given? I have 2 and 3/4 plus 1 and 2/3, and it wants to know what is true about that sum. The first thing I have to do is figure out what the sum is. Remember, sum equals the answer to an addition equation. So I'm going to find this sum first and then figure out which statement matches it. 2 and 3/4 plus 1 and 2/3. 3 and 4 share the denominator 12. So bring my whole numbers over. 3 times 4 gave me 12, so 2 times 4 gives me 8. 4 times 3 gave me 12, so 3 times 3 gives me 9. 9 plus 8 is 17 twelfths, and 2 plus 1 is 3. This is an improper fraction. That means in order to really understand which statement applies, I need to turn that improper fraction into a whole number or a mixed number and add it to my 3. So I'm going to transform this into a proper fraction. 12, how many times will it go into 17? It goes 1 time. That is my whole number. Subtract to see how much is left over. There's 5 left over. This is my numerator. And I keep my denominator of 12. So I have 3 plus 1 whole and 5 twelfths. That means my sum is 4 and 5 twelfths. Now I've got to look. If my sum is 4 and 5 twelfths, which of these statements would be true about 4 and 5 twelfths? It is greater than 2, yes, but less than 3. That is not true about 4 and 5 twelfths. So A would not be my answer. The sum is greater than 3. It is greater than 3, but less than 4. It is not less than 4 because it's a little bit more than 4. So the sum is greater than 4, it is, but less than 5. That is true about my sum. 4 and 5 twelfths, if I think about a number line, it's between 4 and 5. This would be 4 and 1 twelfth, 4 and 2 twelfths, 4 and 3 twelfths, 4 and 4 twelfths, 4 and 5 twelfths, and there's my number right here, and I would keep going on and on and on until I get 4 and 12 twelfths. Okay, so my number is between 4 and 5. It's greater than 4 but less than 5, so the best answer choice for me is C. I'm going to double check D. The sum is greater than 5 but less than 6. It is not greater than 5, so my best answer choice for number 5 would be C. Going to move on to number 6. Number 6, Tia and Nia are training to run a marathon. Tina runs 1/2 mile, while Nia runs 2/5 mile. How much more does Tia run than Nia? When I see those words, how much more, that lets me know they want to know the difference between the greater one and the lesser value. So my greater value is 1/2. My lesser value is 2/5. So I need to figure out the difference between those two. Difference equals the answer to a subtraction equation. Therefore, I'm going to solve 1/2 minus 2/5. They share the denominator, because I got to change my denominator, 10. I said 5 times 2 to get 10, so I'm going to do 2 times 2 to get my new numerator up here, and that's 4. 2 times 5 to get 10, so I'm going to do 1 times 5 here, and that's 5. 5 minus 4 is 1/10. So that means that Tina runs 1/10 more miles than Nia. So my best answer choice here is D, 1/10. I'm going to move on to number 7. Number 7 says, Martha is making 3 recipes for Thanksgiving. The chocolate pie requires 1 1/2 cups of sugar. The cranberry sauce uses 1 3/8 cups of sugar. The tea requires 3/4 cup of sugar. If she had 5 cups of sugar to begin with, how much will be left after Martha makes the 3 recipes? Okay, so if I'm thinking about this problem, I can do cubes along the side to help me solve it, to organize my information, because it's a lot of words. I can circle my important numbers. The important numbers have to deal with the sugar, okay, and the fact that she had 5 cups of sugar. My question is, how much will be left after Martha makes the 3 recipes if she had 5 cups of sugar to begin with? I need to box the important words. The important words here are, or the action words here, how much will be left, okay, if she had, okay, and it's the fact that she's making 3 different recipes that all require sugar. My first step is to figure out how much total sugar she needs for this recipe. I know she needs 1 1/2 cups for the chocolate pie. She needs 1 3/8 cups for the cranberry sauce, and she needs 3/4 cups for the tea. I'm going to add all of these fractions together, so I have to think of a common denominator between 2, 4, and 8. Okay, if I list out my multiples, 2, 4, 6, 8, 4, 8, and then I have 8 here. They all share 8. So I'm going to give them a common denominator of 8. I'm going to start from the bottom. 4 times 2 gave me 8, so I'm going to do 3 times 2, which is 6. This fraction doesn't change because I already have an 8 as my denominator, so it stays as 1 3/8. 2 times 4 gave me 8, so I'm going to do times 4 up top. That's 4 8s, and I have my 1 to bring over. I have to add all of these together. 4 plus 3 is 7. Plus 6 more is, 4 plus 3 is the 7. And then if I add 6 more, that is 13 8s. And 1 plus 1 is 2. So I have 2 and 13 8s. I can stop right here and not transform this because I have a second portion to do. But it's going to be easier to go ahead and turn this into a proper fraction altogether. So I'm going to see how many times will 8 go into 13, because I'm transforming this piece into a proper fraction. 8 will go into 13 1 time. So I subtract 8. I get 5 left over. The 1 is my whole number. The 5 is my numerator, and I keep the same denominator of 8 from over here. So I really have 2 plus 1 whole and 5 eighths. 2 plus 1 whole and 5 eighths is 3 and 5 eighths. I'm not done yet because it says that she has 5 cups of sugar, and we have to figure out how much will be left after she uses 3 and 5/8 cups of sugar for all 3 of her recipes. So I'm going to take 5 and subtract 3 wholes, 5 eighths. Okay? 5 minus the 3 wholes and 5 eighths. I'm going to rewrite it this way. That leaves me with 2 wholes, or actually, I'm sorry, I'm wrong here. Since I have the 5 here, this is like 5 and 0/8, simply because I don't have a fraction over here. So now I have to borrow from my 5 because I don't have enough to subtract that 5/8 away. So I'm going to change this to a 4. And I have to figure out, okay, how can I make this whole that I borrowed translate over here to my fraction? Well, I can add 8/8 because that equals 1 whole still, but it's in fraction form. So I end up with 4 and 8/8 minus 3 and 5/8. 8 minus 5 is 3/8, and 4 minus 3 is 1. So my leftover would be 1 and 3/8. My best answer choice for number 7 is A, 1 and 3/8 cups.
PBIS meeting will be in the media center starting right now. PBIS meeting is starting in the media center right now. Thank you.
I'm going to go over number 8 next. Courtney found 2 lizards in the yard and measured them with a ruler. One lizard was 4 and 5/12 inches long. The other lizard was 1 and 3/4 inches long. How many inches longer was the longer lizard? Obviously, the longer lizard was 4 and 5/12 because it has a bigger whole number. And it wants to know how many inches longer. That means I'm subtracting here because it wants to know the difference between the very long one and the shorter one. And when I think difference equals the answer to a subtraction problem. Or a subtraction equation. Okay, so I have 4 and 5/12 minus 1 and 3/4. Right now I don't have a common denominator, so I need to get that. My whole number still just hangs out, but I've got to find my common denominator. 4 and 12 share the denominator or the multiple 12. 4 times 3 is 12, so 3 times 3 is 9. This stays the same because it already has a denominator of 12, so I make that a 5. So I have 4 and 5/12 minus 1 and 9/12. I cannot take 9 away from 5, so I'm going to borrow from my whole number. This is a 3. How do I add a whole number in fraction form? Well, I look at my denominator. It's 12. In order to make a whole, or add that whole that I borrowed in fraction form, I have to have a numerator of 12 as well, because this equals 1 whole. So now I have 3 and 17/12 minus 1 and 9/12. Okay. 17 minus 9 is 8/12, and 3 minus 1 is 2. I'm going to look at my answer choices for number 8. 2 and 8/12 is indeed an answer choice. So A is my best answer there for number 8. 2 and 8/12. Moving on to number 9. Chloe has a piece of wood molding that is 27 inches long. She cuts the molding into 4 pieces of equal length. How long is each of the smaller pieces? So the total length of her wood is 27 inches. That's total. And she wants to cut into 4 pieces that are equal in length. That means I'm dividing this 27-inch long piece of wood into 4 parts. So 27 divided by 4. Well, we know fractions mean division. So this means 27, and that fraction bar is the same as that division sign, 27 fourths. That's how long each one would be. Well, unfortunately, for number 9, I don't see 27 fourths as an answer choice. That means they want me to turn it into a proper fraction, because right now it's improper because my top is bigger. So I'm going to see how many times will 4 go into 27. 4 will go into 27 6 times. Okay? 4 times 6 is 24, so I subtract that. Okay? 6 is my whole number. That's how many wholes I can make from this fraction. 27 minus 24 is 3. So I have 6 wholes and 3 fourths as my answer, because I keep my same denominator, and this is my numerator. So 6 and 3 fourths is answer choice B, and that is my best answer. Number 10. This one required you guys to read a chart, okay? And really, charts are nothing more than information compiled in one space. Sometimes it can be a little difficult to read. But it says 4 people are organizing 4 different parties during the weekend. Each party is ordering a certain amount of pizza for its guest. The table below shows how much pizza is being ordered and the number of guests at each party. So this chart basically tells me who organized the party, how many pizzas they plan to get for their party, and how many guests have to split that pizza. Okay? Again, I'm not sure if I put this up there, but this is number 10. So we're looking at who organized the party, how many pizzas that party person plans to order, and how many guests have to split that many pizzas. Okay? I'm not splitting guests into pizzas, but I am splitting pizzas amongst guests. So what I'm going to do, because I want to figure out who gets the most, which guest will have, at which party will each guest have the most pizza. So I'm going to solve each of these equations. Basically, they're division equations. So at Jacob's party, he's ordering 5 pizzas that he's going to split amongst 8 friends. So that means each person gets 5/8 of a pizza. Kayla's party, she's ordering 6 pizzas, and she's going to split it amongst 10 friends. That means each person gets 6/10. Landon's party, he's going to order 2 pizzas, and each friend gets, he's going to, order 2 pizzas and split it amongst 4 friends, which means each friend gets 2/4 of a pizza. And then Mindy's party is going to order 11 pizzas and split it amongst 20 friends, so they get 11/20. Now, I can't decide which fraction is larger or who gets the most with these denominators all different. So I'm going to try to just point to a denominator, maybe that they share. So I'm going to look at 8, 10, 4, and 20. Okay, now if I count by 8s, it's 8, 16, 24, 32. Then I get to 40. If I count by 10s, I have 10, 20, 30, 40. If I count by 4s, I know I have 4, 8, 12, 16, 20, 24, 20, 20, I missed something there. 4, 8, 12, 16, 20, 24, 28, 32, 36, and then 40. And if I count by 20s, I have 20, 40. So it looks to me that they all share a 40. Okay? So I'm going to set them equal to a denominator of 40 to try to compare to see who has the bigger numerator in general. 8 times 5 is 40, so I'm going to do 5 times 5, which is 25. 10 times 4 is 40, and 6 times 4 is 24. 4 times 10 is 40, and 2 times 10 is 20. And 2 times 20 is 40, and 2 times 11 is 22. The biggest numerator is 25/40. So my best answer choice would be Jacob's Party because they get the most out of 40 pieces. When I made all my numerators and denominators equal, I see that Jacob's Party gets the most. So I'm going to, letter A is my best answer choice here. I found a common denominator for them all, then looked at their numerators to see who had the biggest numerator. When you're comparing fractions, it's important to find a common denominator and see who has the biggest numerator. Okay? Then I'm going to do number 11. Our teacher gives, or let me write number 11 here. Our teacher gives 9 sheets of papers to your group of 4 students. If you share the paper equally, how much paper does each student get? So, this is another one of those division problems. 9 sheets of paper divided among 4 students. I know this division means fractions as well, or fractions mean division. So 9/4 here. I don't see 9/4 as an answer, so I am going to turn this into a proper fraction. How many times will 4 go into 9? 4 will go into 9 2 times without going over. Subtract 8, and I get 1 left over. 2 is my whole number. That's how many wholes I can make from this improper fraction. And 1 is my numerator. So I have 2 wholes and 1/4 because I keep the same denominator. So my best answer choice is B, 2 wholes and 1/4. You could also think of it as splitting 9 tally marks amongst 4 circles. So this gets 1, this gets 1, this gets 1, this gets 1, then this gets 1, this gets 1, this gets 1, and this gets 1. And I have 1 left to split amongst 4 people. That means each person would get another 1/4. 2 and 1/4. That's another way to think about it. All right, we're going to move on to number 12. So number 12 says Carl has 60 marbles in his collection. 2/3 of the marbles are red and 1/5 of the marbles are blue. How many more of Carl's marbles are red than blue? Okay, so I know that red is the greater number. It says how many more. That means I'm finding the difference between the greater amount and the smaller amount. Difference equals the answer to a subtraction equation. So I'm going to take red marbles, which is 2/3, and subtract 1/5. I've got to find my common denominator here. 3 and 5. They share the denominator 15. 3 times 5 gave me 15, so 2 times 5 is 10. 5 times 3 is 15, so 1 times 3 is 3. 10 15ths minus 3 15ths equals 7 15ths. So 7 15ths, or answer choice C, is our best answer. We didn't really have to worry about the 60 or trying to figure out this other thing. We just needed to focus on the fraction. Okay, that's the biggest part. That 60 and the 28 is kind of there as distractors, or for some of you that may understand how to convert these fractions and multiply them by whole numbers, you might have understood that part. But the biggest piece we needed to worry about was the fractional answer, which was 7 15ths, or C. Okay, number 13 was a bonus. but I'm going to go over it anyway. That's why if you're looking at your test and it says out of 12 questions, because number 13 was a bonus, it didn't count as part of your denominator there. All right, 6 friends are sharing a cake. The cake is cut into 15 pieces. How many pieces of cake will each friend get if the cake is divided equally? So, 6 friends are sharing a cake. The cake's cut into 15 pieces. I have 15 pieces to share amongst 6 friends. So 15 divided by 6. This equals 15/6. I have to convert this into an improper or a proper fraction because right now it's improper. How did I know that this equaled 15/6? Because that division sign means the same thing as this fraction bar. They're the same. So I'm going to see how many times will 6 go into 15. 6 will go into 15 2 times. This is my whole number. This is how many wholes I can make. I subtract 6 times 2, which is 12, and I get 3 left over. This is my numerator, and I keep the same denominator that I had over here. So I end up with 2 wholes, 3, 6. Okay? 2 wholes, 3, 6. That means each person, oh, I don't see 2 wholes, 3, 6. This must means I have to reduce. So what can I divide 3 and 6 by? I think I can divide both of them by 3. This gives me 2 wholes, and 3 divided by 3 is 1. 6 divided by 3 is 2. 2 and 1/2. Another way to think about it is 3 is half of 6, so this must be equal to 2 and 1/2. So my best answer choice is B, 2 and 1/2. Hopefully the test correction video was helpful for you, and I will see you guys tomorrow. Don't forget to get your test signed tonight.